Hello and welcome to Maths with Kirin. I'm sure it's nice for you to be able to hear me this time. I am obviously Kirin. I'm going to be running through some maths with you today. We are kind of just testing out all of this technology, so we haven't advertised anything yet. We won't have any viewers, or we're not expecting to have any viewers, so we won't have any questions to run through, but I am going to go through some algebra skills with you. We're looking at simplifying in algebra, so adding, subtracting, multiplying, dividing, powers of powers, and square roots. These skills are really important to have for level 1 algebra. The questions that we're looking at today you won't see in your algebra assessment. They're not difficult enough, but these skills come up in all sorts of areas of algebra, particularly in solving equations, so they're really important to have. So we're going to get started. Okay, so the first thing we're going to look at is adding and subtracting algebraic terms. So in algebra, if we want to add or subtract terms, we can only do that with what we call like terms. So these are terms that have exactly the same variables, and the variables have to have the same powers. Okay, so I'll go through a couple of examples just to help spell that out with you, but that's just really important to remember when we're adding and subtracting. We can only add and subtract like terms. Okay, so I've got two examples. In this first one, we've got 3x plus 2x squared minus 5x plus 7. So when we're looking for like terms, we need the same variable, but the variable also needs to have the same power. So 3x and 2x squared, while they both have x as a variable, they're not like terms because this is an x squared and this is an x. Okay, so the only like terms I have in this first question are the 3x and the minus 5x. So if we've got 3x's and then we subtract 5, we end up with negative 2x's. The 2x squared, there are no other x squared terms, so I can't simplify that any further. And the 7, there are no other numbers, so I can't simplify that any further. So this is as simplified as this expression will get. Negative 2x plus 2x squared plus 7. Okay, now some people with convention will write the x squared term first, then the x term, then the 7. It doesn't matter what order you write them in, as long as you have a negative 2x, a positive 2x squared, and a positive 7. Okay, but you'll often find the answers written in this order, with the highest power of your variable first, going down. In our second example, a little bit more complicated, 4x squared y plus 3x minus 2xy squared plus 8x squared y minus 4x. So I've got quite a lot going on. My advice when you've got so much stuff is just to start with the first term, work your way along the question and see if you can find any like terms. If you can, simplify those and then move on to the next term. Okay, so if we've got a 4x squared y, we're looking for any other term that has an x squared y. So if we go along, this is close, but not close enough because my x is not squared. Okay, so that's not a like term with this one here, but this one is. We've got x squared and a y. So if we've got 4 x squared y's and we add 8, we get 12 of those. So 12 x squared y's. Notice that nothing about the variables is changing. We're only changing the coefficient. That's just how many of those things that we have. So moving on to our next term, 3x. So we just look through the rest of the expression here, and we've got a negative 4x here. That's the only other like term. So 3x minus 4x gives us a negative x. Negative 2xy squared. We've got no other like terms. So we've got our negative 2xy squared, and that's it. Okay, so adding and subtracting, just remember we need to have like terms. The next thing we're going to look at is multiplying algebraic terms. So unlike adding and subtracting, we can multiply anything together. And so we don't have to worry so much about using like or unlike terms. If we multiply something by itself, the thing to remember, particularly in algebra, is that you're squaring that thing. So just like when we go 5 times 5 is the same as 5 squared, x times x is the same as x squared. Okay, so when we're multiplying variables, we're actually changing the powers. If you have a coefficient, you'll multiply the coefficients together just like you normally would, and then we look to use this skill in order to simplify the variables. So let's have a look at our examples. So the first one here, we've got 4x cubed times 2x times 5. So if we multiply all of the coefficients together, 4 times 2 is 8, and 8 times 5 gives us 40. And then we've got an x cubed and an x. So if we've got x cubed and we're multiplying that by an x, then we get x to the power of 4. Okay, these three plus this 1 that we've got here. In our second example, 10x squared y times 3xy cubed times 2xyz. Again, start with the coefficients. 10 times 3 is 30, times 2 gives us 60. And then we look at our x terms. So we've got an x squared here and an x, so that would give us x cubed, and we've got another x here, so we've got x to the power of 4. Moving on to the y's, y times y cubed would give us y to the power of 4, and then another y gives us y to the power of 5, and then we've got the z, and no other z's, so we just have z in our answer like so. Okay, so multiply out the coefficients, and then you just take each variable in turn, multiplying by adding those powers together. Okay, so from here we're going to look at powers of powers, because this is really multiplying as well. So when you see this, you'll have an algebraic term in brackets, and then you'll have a power, or sometimes we call them exponents, outside of those brackets. Okay, so when we have that, we want to raise the entire term that's inside the bracket to that power that's outside the bracket. To do this, we take our coefficient and we raise it by the power, as we normally would a number, and then any variables are raised to the power by multiplying the exponents. And I'm just going to show you sort of why that works as we go through this example. So, oops, that's a little bit crooked. This first one here, we've got 3x to the power of 4, that's in brackets, and we're raising that whole expression to the power of 2. So remember when we said before, we're just going to have a wee side note over here, when we raise something to the power of 2, we're multiplying it by itself. So this is really saying 3x to the power of 4 times 3x to the power of 4. Now we know how to do this, we just did it in our previous skill. 3 times 3 gives us 9. Then x to the power of 4 times x to the power of 4 will give us x to the power of 8. Okay, so that's what's happening. When we look at this, we can sort of speed up that process. If this is a really high number, you're not going to want to write this out a huge number of times. So 3 times 3 is where that 9 comes from. That's the same as 3 squared. Okay, so we're going to go 3 squared gives us that 9. Okay. And then we've got this x to the power of 8. Well, that's because we have x to the power of 4 times x to the power of 4. And when we're multiplying with our variables, we end up adding those powers. It's like 2 lots of 4. So we're adding 4 plus 4, or 4 times 2. So when we are raising x to the power of 4 to the power of 2, what we're really doing is saying we've got x to the power of 8, because we've got 2 sets of that x to the power of 4. Okay, so if we see that with another example, I'll just leave that top one there so you can still kind of see. To the power of 3, if we expand this out, we've got 2x cubed y to the power of 4 times 2x cubed y to the power of 4 times 2x cubed y to the power of 4. We don't really want to have to write that out. So, like we did before, this 2, if we had it written out 3 times, would have 2 times 2 times 2, or 2 to the power of 3. So 2 to the power of 3 is 8. So this is 2 to the power of 3. That's where that comes from. Okay, and then we just take our variable one at a time. X to the power of 3, and then raise that to the power of 3. Well, we know that's x to the power of 3 times x to the power of 3 times x to the power of 3. So we've got 3 sets of x to the power of 3's, which will become 9. Okay, and then with our y's, same thing. We've got 3 sets of y to the power of 4. We end up with y to the power of 12. Okay, so we're raising the coefficient to the power outside the brackets, and you are multiplying the power of the variable by the power outside the brackets. Okay, and remember, this is why. This is why that works. Okay, The next thing, because it kind of ties in with that, is looking at square roots. I know I'm going through lots of skills here, but these will come up time and time again. If you need to, if you're not watching this live, you can pause and take a break whenever you like, if you just need to have a bit of a rest. We've got two more to go through. We've got the square roots and we've got the dividing. Okay, and then we're done. So for square roots, again, we're going to just take a bit of a side note so I can kind of explain why it works. So when we're taking square roots of algebraic terms, we take the square root of the coefficient, so that as we normally would for a number, and we end up halving the power of the variables. And we're just going to go back to this in order to show you why we end up halving. So if we take our 9x to the power of 8, okay, and we're going to square root that. Now we already know that because we already know that came from our 3x to the power of 4 all squared. Okay, so when we squared that, 3 times 3 is 9. X to the power of 4 times x to the power of 4 is x to the power of 8. So because square root is the opposite of taking a square of something, because we end up multiplying the power of our variable by the power outside the bracket, to undo that, we need to divide by the same number. So we divide by 2, the same thing as halving. So if we took the square root of 9x to the power of 8, the square root of 9 is 3, and then we halve our power, we get x to the power of 4. Okay, undoing that squaring that we had before. So if we go to a couple of examples for square roots, the square root of 100x to the power of 6, we take the square root of 100, that's 10, and then we halve that power, so we get x to the power of 3. All right, second example, square root of 64, that's 8. X to the power of 10 is x to the power of 5 when we halve the power, and y to the power of 4 becomes y to the power of 2. Okay, so halving algebraic expressions. No, so sorry. Taking the square root of algebraic expressions, we take the square root of the coefficient and we halve the power. Cool. One more thing, which is dividing. Okay, so in algebra, when we write division, you'll find that we often use fractions, and that's partly because it actually makes simplifying a lot easier to see. It's a lot more visual. Okay, so you might find that using a fraction might help you when you are dividing in algebra. You can sort of find the things that you want to simplify. So to do this, like everything else, the coefficients you just simplify as you would a normal fraction, and then the variables you use cancelling. Okay, so we're going to look at the powers in order to cancel. Okay, and again, I can show you why that works. So if we just take our wee side, we've got 16. X to the power of 6 is really x times x times x times x times x times x. So we've got 6 x's, and then we've got 4. There should be a times in between, and we've got 2 x's here. So 16 over 4, we can simplify that as we would a normal fraction. 16 over 4, well, that's just the same as 4. 4 fits into 16 4 times. If we have x divided by x, well, if we take something and we divide it by itself, so for example, 5 divided by 5, well, that's 1. 10 divided by 10, also 1. Negative 3 divided by negative 3, 1. X divided by x, well, that's also 1. So if we've got an x and we're dividing it by an x at the bottom, well, that's just 1. So I don't need those there. They're unnecessary. And then again, I've got an x here and an x here. That's just 1. They're unnecessary. These ones, I don't have anything left at the bottom to create any ones with, so I'm still left with those. So we end up with 4 from our 16 divided by 4, x to the power of 4, because we've got 4 x's here that we can't simplify any further. Okay, so when we have 16x to the power of 6 divided by 4x squared, 16 divided by 4 is where our 4 comes from. And then if you look, we've got 6 x's and we've got 2. So we can take these two and cancel out 2 of the ones at the top, which is what we did over here. So we are left with x to the power of 4. Okay, 6 minus 2 gives us that 4. Second question, 18 and 12. Now 12 doesn't fit into 18 very nicely, so we want to look for a common factor, our highest common factor. If possible, 3 fits into both of those, but 6 also fits into both 18 and 12. So it's easier if we use the 6, because then we won't have to simplify again. Okay, so if we take 6, that goes into 18 3 times, and it goes into 12 twice. It pays just to check these numbers, make sure you can't simplify them any further, just in case you haven't spotted a highest common factor. All right, but 3 and 2, there's no common factors aside from 1, and that's not going to help us in this case. So now we move on to our variables. If we just take our x's to start with, we've got 3 at the top and 1 at the bottom. So we can take 1 at the bottom and cancel with 1 at the top, which just leaves us with 2 x's. We're unable to simplify. Looking at the y's, we've got y to the power of 5 at the top and y to the power of 9 at the bottom. So we can take our 5 y's from the top and cancel with 5 of the y's we've got multiplying at the bottom down here. So 5 of those will disappear, but we are still left with 4. So we get 3x squared over 2y to the power of 4. That's as simple as we go. Can't simplify anymore. So that's it. All right, so for division, simplify the coefficients as fractions, sort of as normal fractions, and then for the variables, you're looking to essentially subtract those powers. You're cancelling them down to make that a lot more simple. Awesome. So I know that was a lot of content. Thank you for persevering. If you need to go back and rewatch things, then certainly do. If you've got any questions, then you can email them through to me. I'll write my email address down on this piece of paper. So it's just quite simply mathswithkirin@gmail.com. So you can email through any questions regarding that content. There it is. To me, and I can address those on the Thursday Q&A sessions, or you can send a message and you can access the messaging through our page, and I can answer those questions for you during the Q&A. When we do our live stream and we have an audience, then I can answer questions as we kind of go through, as I see them pop up in that chat. But just for this one, because we don't have any live viewers, we're looking at using that email, or just contacting through the Facebook page. Awesome. Okay, well, thank you. I hope that was really helpful. As I said at the beginning, you won't see questions like that in your algebra assessment, but you will use those skills in lots of different areas of algebra. So it's really important that you have a really good understanding of those, because it will really help you to get some marks. Even if you don't get through an entire question, using some of those skills might be enough for you to be able to get an achieved mark for that particular question. Okay, and that's really useful to know. Cool. Well, I'll see you next time. Thanks for watching.